Have you ever really thought about what happens in that split second after you hit post? Today, we're pulling back the curtain on the incredible engineering that powers your newsfeed. I mean, this is one of the most complex pieces of software that millions of us use every single day. So, let's just dive right in. Right? You open an app, you swipe your thumb, and boom, a never-ending stream of updates just appears. It feels so simple, almost magical. But behind that effortless scroll is a monster of an engineering challenge, a system that's been obsessively designed to feel like it's doing nothing at all. So how does it really work? Okay, to really get a sense of the scale we're talking about, let's just start with this number, 10 million. That's how many daily active users this system has to support from day one. That's not a goal for the future, that's the starting line. Every single decision we make has to work for millions and millions of people all at the same time. To wrap our heads around this whole thing, let's just follow the journey of one single post. The moment you tap that publish button, a whole chain reaction kicks off. This is what engineers call the feed publishing flow. So you publish your post. The first thing it does is hit a load balancer. You can think of that like an air traffic controller for the internet, just directing your request where it needs to go. From there, a post service grabs your content and saves it in a database. But the real magic, the most critical step, is next. The Fanout service. This is what begins the whole process of getting your post out to your friends. Let's actually zoom in on that Fanout service for a second, because this is where the real engineering puzzle is. Fanout is just a fancy word for taking your one post and blasting it out to the news feeds of all your friends. And believe me, the way a system decides to handle this is probably its most important decision. And that brings us to the big showdown in news feed design, the battle of push versus pull. Now, this isn't just some minor technical detail. This is a fundamental choice that has a massive impact on how fast your feed loads and really how the whole system performs. The easiest way to think about this is like a newspaper. The push model, that's like having a subscription. The second the paper is printed, it gets delivered right to your door. For a news feed, this means your feed is already built and waiting for you, so it loads super fast. The huge problem, though, imagine a celebrity with millions of followers posts something. The system has to deliver millions of newspapers all at once. It's a massive amount of work, especially since a lot of those followers might not even be online. Now, the pull model is like you having to go to the newsstand to get your paper. The feed is only built when you show up and ask for it. This is way more efficient for people who don't log in often, but it means everyone experiences a bit of a delay while their feed gets put together. So you see the dilemma. Luckily, you don't have to pick just one. The smartest play here is a hybrid model. For most of us, the system uses that fast push model, so our feeds are ready to go. But for the celebrities, the huge accounts with millions of followers, it smartly switches over to the pull model. Their followers just grab the updates when they open the app. This one little trick is how the whole system doesn't just collapse every time a famous person posts a selfie. Okay, so we've seen how a post gets into the system, but that's only half the story, right? Let's flip the coin and look at how the system actually builds the feed that you see on your screen. This is the retrieval flow. The second you open the app, your phone sends out a request. A newsfeed service immediately grabs a simple list of post IDs from a super fast memory bank called a cache. Now notice, it's not getting the full posts yet, just the little ID numbers. It's a shortcut. Then, the system uses those IDs to quickly gather up all the other pieces and assembles what's called a fully hydrated feed to send back to you. So what on earth is a fully hydrated feed? Well, it's basically the process of bringing the data to life. It's about turning a simple, boring identifier like post ID 789 into everything you actually see and interact with on your screen. The system takes that ID and, in a flash, pulls in the username, the profile picture, the actual text, any photos or videos, and the latest like and comment counts, the whole shebang. So as we zoom out, you start to see a theme here, right? It's all about trade-offs. Every single step is a careful balancing act between speed, cost, and complexity. And making all of this feel so instant requires a powerful secret weapon that's really the foundation of the whole system's performance. And that weapon is an incredibly aggressive, multi-layered cache. A cache is just a form of super fast memory. And in this system, basically anything that can be cached is. There's a cache just for the list of post IDs in your feed. There's another one for the actual content of the posts. There's one for your network of friends, one for actions like likes and comments, and even one just for simple things like counting the number of likes. This is the secret sauce. This is why it feels so fast. By keeping all this data in these lightning-fast layers, the system avoids having to do slow, clunky database lookups. And honestly, that brings us to the biggest takeaway from all of this. There is no one single correct way to build something like this. A perfect design just doesn't exist. It's always a series of very deliberate choices and compromises, all designed to solve a very specific set of problems at an absolutely mind-boggling scale. So, the next time you're just casually scrolling through your feed, maybe take half a second to appreciate the incredible, invisible ballet of data and decisions that's happening in milliseconds just for you. It really makes you wonder, doesn't it? If this is what's behind a simple scroll, what other engineering marvels are hiding just behind your very next click?